Another application of right triangle trigonometry has to do with the idea of a bearing. Now, a bearing refers to the direction of motion of any object. You see this a lot when you're talking about ships or airplanes, and when we think about the motion or the direction of that object. Now, there's two ways for us to consider bearing. The first one we're going to look at here in this example is the idea that we are going based simply on the direction of due north. So if I am looking due north here and I rotate clockwise 32 degrees, my object is moving 32 degrees with a bearing of 32 degrees, and it's 32 degrees off of due north. And this is a little bit different from our angle of rotation we've looked at before. We want to make sure that we understand that when we are talking about this bearing method here, that we are rotating clockwise from due north. Here's another example of that case. If we have if our bearing is 164 degrees, well, based on due north, we rotate clockwise 164 degrees. You can see that my object would be moving in this, what I would consider kind of a southerly direction. So just in this particular method, we are talking about simply a due north heading and then, or a due north and then rotating off clockwise off of that due north. So we have this example here where we have a radar station. Let me pull that in. We have a radar station, A and B, that are on an east-west line, 3.7 kilometers apart. Station A detects a plane on a bearing of 61 degrees. Station B simultaneously detects the same plane with a bearing of 331 degrees. We want to identify or find the distance then from station A to the plane. So of course, the first thing we want to do is sketch what they're talking about here. So we know from this sentence here that the A and B, stations A and B, are on an east-west line. So I'm going to come down here and I'm going to say, here's station A and here is station B. And those stations are 3.7 kilometers apart. And I drew them east to west or left to right. Now, station A detects a plane, which we'll call at location C, and it's on a bearing of 61 degrees. So because of the way that this is stated, that it is simply a bearing of 61 degrees, we are assuming it's based off that due north. So we come over here and I'm going to draw a line representing due north. Now, because A and B are east and west from each other, due north would of course be perpendicular to that. And when I rotate 61 degrees, I'm rotating counterclockwise. I'm rotating clockwise. So I would rotate in this direction 61 degrees, and we're going to say that rotation is going to give me a line here. And the next part of, and somewhere out here is the plane C. Now let's identify the bearing of that plane based on station B. It says that it has a bearing of 331 degrees. Okay, so I'm going to come here. I'm going to draw my northerly heading, or my north, and I'm going to rotate 331 degrees clockwise. So rotating 331 degrees puts me rotating all the way around to 270 plus a little more, right? Because when I rotate, starting here at this position, if I rotate, 3/4 of the way around a circle, I've gone 270 degrees plus a little bit more. Now it's this interior angle, it's this little bit more, it's this value inside of this triangle, if you can visualize that I'm wanting to determine. What is this angle that ultimately is going to be in here? What is that angle inside of this triangle? Well, I can find that by taking my 331 degree rotation, and let's just label that. That's 331 degrees. So 331 degrees minus the 270 that I already rotated is going to give me an angle of 61 degrees, which is what is on the inside in here. So this is represented by 61 degrees inside. Okay, so what we need to do now is we have kind of some angles going on, so we can kind of start piecing this together a little bit more. This intersection here for both of the bearings from station A and station B is represented right where the plane is at, which we're going to call C. And you can see that I have some angles here, and I'm kind of wanting to, first of all, if I want to use trigonometry, I have to make sure that the triangle that I have just created here is a right triangle. So we would need to know we don't know if it's a right triangle right now, but we would need to know what are the angles here on the inside. So coming back over here to the first bearing that we identified, remember we said that if we have north and east, we have a right triangle here. If this angle of rotation is 61 degrees, then the interior angle, this angle inside at A, has to be 90 minus 61 because this is a right angle. So 90 minus 61 is going to be 29 degrees. So this interior angle is now 29 degrees. I know over here already that this interior angle was 61 because we determined that already by our calculation. Now we do want to check and make sure, does 29 plus 61 equal 90? Okay, so we want to just make sure, and it does. 29 plus 61 does in fact equal 90, and so therefore this is a right triangle. Remember, we can't apply trigonometry unless we're using right triangles. So now that I know that I am indeed using a triangle, a right triangle, I can use my trigonometry. We want to identify what is the length, right? What is this distance here from A to B? And I'm going to use some trigonometry because I know already that I have a side here. And if you're looking at this triangle here, you can identify that the known length that we have, this 3.7 kilometers, is across from the largest angle, meaning it's going to be the hypotenuse. And I want to know what is this value here. Now, depending on which of these two angles we choose would depend on whether or not we use, whether we're going to use an adjacent side or an opposite side, in other words. Now, I'm choosing to identify this measurement here by talking about cosine. So the cosine is defined as adjacent over hypotenuse. So the side adjacent is going to the angle, right? This is the side I'm looking for, and so therefore I'm going to use angle 29. That's going to be equal to this little side B divided by the hypotenuse of 3.7 kilometers. And now we can solve this algebra problem here. I would multiply both sides by 3.7. So 3.7 times the cosine of 29 degrees is equal to B. And when I do that in my calculator, making sure that it's set to degree mode, I find out that B is equal to 3.2 kilometers. And that's how I identified this side right here. Now keep in mind that I probably could have used sine. Sine would have been using angle 61, where I would have used opposite over hypotenuse to find the same measurement. And this is how we would go about using this first method of bearing.